Hello everybody, I'm Harish Kumar, currently pursuing computer science and engineering from SM College of Engineering. Today, in this YouTube video, we are going to discuss about RapidMiner and how I used RapidMiner to develop my ML and DL models to predict the data scientist salary for the year 2024. So first of all, what is RapidMiner? So RapidMiner is a tool which is used to develop ML and DL models. It has a very rich GUI and makes it very easier for us to develop ML and DL models without even coding and without even using GPU. So generally we use Google Colab to make ML and DL models, and you have to code in it. But RapidMiner has done all the coding for you, and you just have to drag and drop the elements that you need. So it looks like this. Yeah, it looks like this. You just have to search for whatever you're doing here, and then you just have to drag and drop that over here. So yeah, we'll move on. So my work is to predict the data scientist salary for the year 2024. So all of us know that recession is happening and there are layoffs all over the world. So my idea is to predict the salary for data scientists. So moving on, directly to the data set. I've taken the data set from Kaggle, and it has 11 fields, and it looks similar to like this. So yeah, it looks like this, and we are going to process this data set and apply several different models on it. So I performed several EDAs, exploratory data analysis, using RapidMiner, and I found a few similarities among the data, and I've used them to pre-process things. So directly moving on to my methodology. So I use RapidMiner to first of all pre-process the data set, and then we moved on to auto modeling. So I pre-processed the data set using the turbo prep method, and we moved on to auto modeling. We compared the results of various models that are being applied. We applied six different models on the data set, and we found out that Regression tree and gradient boosting gives more better results when compared to the rest, and we optimize the parameters of Regression tree, and we apply ensemble techniques to improve the results also. So this is the methodology that I did, and let me go on explaining them. So this is the data after pre-processing. So I use the turbo prep method to remove and replace the null values, removing low quality values, and low quality and highly correlated data. So I also remove the outliers, and feature selection was also performed. So I also did normalization to pre-process the data set. So this is the data set after pre-processing. Initially I had I had 11 columns. I had 11 different columns from work here to company size, and now after pre-processing I only have 5 different columns. And this is the correlation matrix after pre-processing. So this is the statistical data after pre-processing. You can see that the missing value is 0.0, and IDness is also 0.03, and stability is 65.47. So moving on, I sent the data set after pre-processing from turbo prep to auto modeling. So auto modeling did all different sets types of modeling and gave up the results to me. So this is a generalized linear model, deep learning, decision tree, random forest, gradient boosting, and support vector machine. So you can easily find, this is a graph for root mean square error, and this is the runtime. So you can easily find decision tree and gradient boosting techniques are performing well when compared to the rest of the models. So what I did was, since it gave lesser errors when compared, since decision tree and gradient boosting gave lesser errors when compared to the rest, I thought we could optimize the parameters of decision tree, or apply ensemble techniques to improve the accuracy. In this case reduce the error, because it's a regression problem. So this is a this is a prediction graph after applying decision tree model. So you can see that the model is really performing well because you get a defined line, but then you have a few inaccuracies here. So by optimizing the parameters, you can remove them too. So I use RapidMiner to apply least square optimization technique. So this is the first layout. Inside the optimized parameter, you have cross validation, and then this cross validation was done for 10 folds. And inside cross validation, I have the decision tree, and then apply modular performance. So I think I can show you here itself. This is the process, and then when I click this, I have the cross validation, and then decision tree performance and apply model. So you see here the you can fix the folds. Here you can say 10, and then if you auto click up, the process run here and it executes, and you get the results there. So the results will show up here, and just a minute, it's executing. So yeah, so let that execute, but then I've already done and the result is here. So it gave me around this as the error, which is not that low. So what I thought was you can apply ensemble techniques over the decision tree model to improve the result. So I applied a cat boost technique, HG boost, and like GBM over the results that I got, and after doing that, I got the result for light GBM to be as 0.38 and 0.35 for RMSE and R square value, and for HG boost I got 0.38 and 0.36 for RMSE and R square value. So this is comparatively better result when you compare the other different 6 models. So the error has reduced and R square value has increased. But then you see cat boost technique is really performing well, and if you are to optimize the parameters of cat boost as I did here, you get the result to be at 0.056 for the RMSE and 98.6% for R square value. And you can see from here that in the graph that the line and the points really coincide, and the model is highly performing well. So this is a comparative analysis for the RMSE values and R square values for cat boost ensemble techniques, cat boost, light GBM, and HG boost, and you can see that cat boost is really performing well. So yeah, this is what I have developed, and this is the end of the methodology that I performed. And this research has already been done for the year 2021, and the paper proposed used random forest and linear regression, and they got an accuracy of 91 and 94, but I have got an accuracy of 98. Yeah, 98.64, so which is 4% increase. And yeah, this is my research on using RapidMiner. So yeah, that has run and gave us the results. So this is the result for the auto model, and you can click here and see the performance, the prediction charts, and so this is generalized linear model prediction, and this is the decision tree one. Wait, let me show you the decision tree because it performed really well. So yeah, so we come up to the end of this video, and hope you understood what I predicted using RapidMiner. So yeah, thank you.